Hey, there we go. Audio should now be working. Love that for us, right? Don't we love it when the audio like works and I can talk, and it's great. It's absolutely great. Absolutely great. Okay, how are y'all doing tonight? Let's see here. I am still posting the link a few places. So I'm just gonna finish up with that. But yeah, so tonight we're gonna be doing a 180 on the microscope. Gonna be flipping it around and working on the other swing out door. So we've got right down there, we've got the DC power supply swing out. On the other side, there's another door on that side, and on that door, there is the 2 ion pump supplies and the stage motion controller. So we got that. And then, so we're gonna do the ion pump supplies, then we're gonna do the stage, and then we're gonna do the 2 optics boards, and then the detector board and the video board. Just make sure everything looks good in those. And then we're pretty dang close to applying power. Then we gotta get it plumbed. So we gotta actually hook it up to all the plumbing we did. Get water circulating, get the chiller commissioned on it. I've already brought up the chiller, so that's good. And then, yeah, plug it in, and so yeah, we're not applying power quite yet. I think there's a chance we apply power the next like day or two. That's what I'm thinking. Okay, let me finish getting this link posted everywhere. Okay, link is getting posted. I think I just have Mastodon left. Maybe I'll put it up on Instagram too tonight. I haven't put up anything on Instagram in a while to get out a different device, but yeah. So how's your SEM doing, Peter? Oh, if I could spell, this would be done. Opening up. Some interesting. Usually I do this before I go live, but that's fine. Going over electronics, I can relate. You tend to spend a lot of time going over electronics with an SEM. Okay, cool. Let's decided to not cut any holes in the case. Oh, you're keeping it original. Okay. My Super 3 has got several holes cut in the back of it. It had an external scan interface retrofitted in before I ever got it. Did not come with said external scan interface, but it was there. There was one there at some point. Okay, let's switch to this view. Let's figure out what's broken. Okay, what's broken? It's the chat. It's always the chat. Oh, I also didn't turn this camera on. Hey, enough spare pins on connectors. Okay, like the big mil-spec connectors, or? Hey, look at that. There we go. We got a whole nother camera. Doing great. Why did it? Is that level? Well, it's not connected. Why did it disconnect? That's weird. Video format not supported. What? I've not had any issues with this camera. And we're just starting out with issues tonight. That's great. Love that for us. I don't know what I did to fix it. That's cool. So you're just like having like bringing some like extra like micro coax like kind of in on the side of the mil specs. Okay, let's get chat fixed. You know, I'm gonna take like a couple of extra seconds, and I'm gonna actually make chat fixed. I think I think I know how to make it work always. Okay, so I think I need to open it up in a window that I am not signed into. Okay, I think if I copy it from here, okay, pop out chat, copy that. Okay, this one might actually stay persistent. That would be really cool if it does. Okay, nice. So you've already, okay, because I was like thinking like a lot of the mil specs, like I was thinking like some like the big mil specs that they have to like go like between like the two control boxes or console boxes, I guess, or but no, you've already got like the external or the TV scan connector, so yeah, that makes a lot of sense. Cool. And then, sorry, are you using like the TV scan relays then to switch in your external scan, or? Okay, let's work on our, okay, that's the past streams note. So I need the note for the current stream because, okay, so I already copied in yesterday's work. So now we can take out, hey, look, we did everything yesterday. To do. Let's see here. We need to do things. Dismount or photograph dismount IGP connections, IGP supply connections, plural. Dismount IGP supplies, inspect, disassemble IGP supplies, inspect / photograph IGP supplies, clean out IGP supplies, and so you're going to use the, well, when you say, so you're going to use like the existing amplifier for your scan coils? Or the existing TV amplifier? Okay, clean out IGP supplies, reassemble IGP supplies. And then actually the first step, step 0, rotate / reposition the SEM for IGP supply work. Okay. So I think we've got a good to-do list now. Nice, doing differential into the microscope. Whenever you can do it, that's great. That works out so well. Welcome to the chat. Meow no chroma, monochroma. What is the wavelength of a cat? Isn't that the real question? Let's see here. Okay, cool. I think we've got everything set up, except we have a very confused webcam. Let me get that addressed. Logitune. Somebody donated, nice. Don't you love it when critical hardware on your microscope gets donated? Oh, it's not even like looking the right way. Well, that would help if it was pointing the right direction. It still is being weird. Why is it being weird? Welcome to the stream, Maria. Oh, we got quite the crowd tonight. This is looking good. Okay, why is camera exposure being weird? Maybe we'll turn exposure up a little bit. Well, I mean, once it's lit up, I guess we should be okay. Okay, we'll keep an eye on that. You'll need to like tag me if something's like terribly wrong with camera exposure. Well, shall we? What are we doing? Let's move some lights out of the way first, because we're doing some pallet jacking. Okay, a little bit higher on that one. There we go, that looks pretty good to me. So, pallet jacking. We need to clear some stuff off the floor so we can get the pallet jack in and around here. Come on. Okay, put this one up and away. I guess we can swing doors in now because we got all this mounted on the hinges and everything. We got the cables on last night, so we can get this side tucked in a little bit. There we go. That out of the way. Swing that in. Is that gonna stay? It's gonna stay enough. Okay, let's get the pallet jack in here. Now, let's make sure we get that picked up so we don't accidentally pinch that cord. There's actually a few more down there too. Let's get those tucked up here too. Hello all indeed. Now we got a traffic jam over here at the pallet jack in our work cart, but that's been resolved. Got our special low profile narrow pallet jack. I bought this thing just for working on Zeiss microscopes. Man, these things do not have, so FEI microscopes, you frequently need a narrow pallet jack, but you can have a full height one. Zeiss microscopes, you frequently need a narrow low pallet jack, so they're just extra fun. Just gonna make sure I'm not pinching anything. don't see any cables to pinch, so that's good. It's amazing how much shinier my floor is in the corner where I don't walk or roll chairs or do things that scratch it. Welcome to the stream, Martin. Just in time for some microscope palette jacking. What do I want to do? So that door's gonna swing. Okay. We'll just try it. I guess I could have done that a little bit differently, but I think we're gonna get right where we want to be. Although actually I'm gonna set it down and pick it up from that end so that I don't end up in pallet jack stuck in the corner. I like not getting the pallet jack stuck in the corner. Setting it down real gentle. And move it a little bit closer to the back wall so I got more room in front of it to work. Should be just enough room to get the cart around back is what I want. Yep, there is. Cool. Okay, how's that look on camera? Set it down real gentle. How is this looking? I like it. Cool. Well, shall we? So let's see here. This is actually let me move this tripping hazard first. Okay, so we've got three things going on this side of the microscope. We've got the two ion pump power supplies and the stage controller. So the stage controller is water cooled actually, as are most of the electronics on this microscope. So that's got water cooling going through it because it's got all the transistors that drive the stage and whatnot. And then we've also got some plumbing going on over here. So this plumbing is the flow sensor. So that's a flow switch technically, I believe on this one. And so that ensures that we've got adequate water flow. We've also got a water temperature sensor, and that's to ensure we're not overheating the microscope that way. And then, yeah, we've got the two ion pump power supplies here. So these have got fiber optic communication to them. I believe it's actually on Sigma, which is the Zeiss we've got right there. That one is just doing frequency over fiber optic. So it's just pulses at a certain frequency, and that's how it's measuring pressure. On these ones, the fiber optic ports are actually labeled CAN. And I don't believe there's any other control lines going to these, so I do believe these ones are actually fully CAN-based. And then we've got the 48-volt DC in. So that comes from the DC supply that we're working on our last few streams. And then we've got the high voltage connector that actually goes up to the ion pumps. So right off the bat, and this is great. Both of the grounds are loose, and they're actually quite loose. And I'm pretty sure they've been that way for a while. Like I didn't loosen them. I noticed that like when I first opened this door when I received this microscope. So that's cool. We like that a lot. So yeah, that's great. Absolutely great. So we're going to start with documenting connections on the outside so that we make sure that when we put these back in, we've got all the information we need to do that. And then we're going to be taking them apart. I do not believe these ones are fully potted. They might be partially potted. What we really want to look for with ion pump supplies is dust buildup over time can cause some pretty serious issues. Namely, it can arc over and then you can get a fire. And ion pump supply fires are not good. And they usually start because of dust. So this style of supply, it's not as bad. Fires aren't as bad. For everything else, ion pumps that are based off of just really massive transformers, those are bad. Those are very bad. They can supply a lot of current, and the overcurrent protection tends not to trip, or if it does trip, it just resets and starts continuing to keep itself on fire. So we like to avoid that. So we take apart the ion pump power supplies and make sure that they are all nice and cleaned out. So yeah. Well, you know, you could try to use an automotive CAN bus accelerator pedal to the SEM, but you'd have to make it optical. So good luck making an optical automotive CAN bus accelerator pedal. I don't know how you would do that. I don't like it. The optical CAN is an interesting concept, but yeah. So let's bring some cameras in. Actually, let's bring some lights around. It's really dark in there right now. And we'll go ahead and swing out the high voltage supply too. So this is this right here is the electron gun high voltage supply. This is a Spellman supply, and I believe that like most Spellman supplies, this thing is probably pretty much completely potted. I have not opened that up for myself to verify, but if I had to guess, I'm gonna guess potted. We got one down there, that should be helpful. And this one will be our overhead one. Okay, that is some well illuminated IGP supplies. Yeah, all of Spellman's greatest hits. Old ion pump power supplies are 120% absolutely terrifying all around. I've got several of them that I'll probably never use. But I do have one really big ion pump. Like, okay, I have several. I have one that I would actually use. So I might keep like one around for that, maybe like one to be a spare, but I've got way more than that, so I don't need them. They're scary and they're heavy and they're a pain. Hello. Oh, don't want you to tip over there. You know what? I think we're gonna actually, let's just do a quick video tour around them. Wow, what is my ISO at right now? Okay, so Merlin ion pump power supplies. So these are the same manufacturer as Sigma, the high-tech power, but they are a different supply. Let's go manual here and get us some smaller aperture so we can see a bit better. There we go. So we got the two supplies, right? We got the upper one, the gun, and the lower one, the column. And then there's this mode selector switch here. I think it's kind of funny. It's got, you know, A0, A1, A2, B0, B1, and then SEM, right? And I'm like, okay, glad we have an SEM mode. You know, always make sure your ion pump supply is in SEM mode. So I'm guessing it's address and something. And I don't know what SEM mode changes about it, but there might be a manual for these. We've got some very helpful indicators, indicator LEDs. Love some good indicator LEDs. As I mentioned, both of the grounds are loose like this, so that's cool, right? Love that. That's great. Don't we love loose grounds? Who cares about the return current path for one of the most likely to discharge things on your electron microscope is, right? And they are both like that, so that's cool. These are the high voltage connectors for each of our supplies. So that's what actually goes to the pump there. Are these the, like, what is it? The King style? Because you can't really unplug that without cutting that zip tie, so that's fun. I love the varying cable and probably cheapest possible ion pump power supply, so that they deem to be good. And then, yeah, as I mentioned, we got our fiber optic can pair. So that's cool. And then, yeah, this one also, unlike the Sigma power supplies, we've got separate analog outputs for current monitoring. That's I monitor, IMON, and voltage monitoring, VMON. So you can get to a condition with the supplies where you're kind of in like the bottom corner of their operating range, or you're just like, you're super current limited and your voltage is low. So it's like, oh, well, my current's really high, but am I actually pumping anything? And then you look at your voltage and your voltage is only 1,000 volts. And you're like, well, no, I'm not actually pumping anything. I'm just striking a plasma, but it's not high enough voltage to actually pump most species of gas. Like, sure, you'll pump the oxygen out, but you're not going to do much else. I mean, titanium oxide, the titanium does really want to oxidize, so that'll pump at lower voltages. But everything else, 1,000 volts isn't enough. Or sometimes you'll even see them drop lower. So it's nice that we have the two different inputs, so we don't have to try to guess if we're in a current limiting range or not. And as I mentioned, these are our DC supply cables. Those came from our DC power supply box over there. Actually, if we look at it, let's see here. Should be, yeah, that one, VAC/SAT. I believe it is X. These are 48 volt ones, and there's 48 volt ones on that, isn't there? Oh, it's the EHT IGP one. There we go. EHT IGP. And so this is going to be, if I had to guess, X9 and X10. And then I think the main supply itself over here is the 24 volt one, if I'm not mistaken. So the 248s on that are for our ion pumps, and the 24 volt is for our electron gun. And then, so it looks like we might have, so our high voltage connector's on the bottom here. So we're going to guess our highest voltage is going to kind of be in this bottom edge here. Let's see here. We may have some type of potted box, it looks like. Maybe, maybe not, don't really know. And then we got some stuff that's not potted over here for sure, because I can see into it. Don't know how well that's going to work, but yeah, there's something going on over there that's not potted. And then I'm guessing on top we've got basically our control board for this. So yeah, that's what's going on with our ion pump. Power supplies here. Let's take a look at the other end. They're mounted on these shelves. So that's kind of, you know, I believe that's to maintain airflow all around. And then they put them horizontally like this instead of like that because it was, they needed the space. And I can see some dust buildup, just a little bit back there. If there was that amount on like a high voltage board, I would want to get that cleaned off, so yeah, that's what we're looking at. And we've already got, somebody's helping us out already by taking out a bunch of screws that are, well, we've already got a bunch of screws missing. So that makes me think that I am potentially, don't know for sure, but potentially not the first person here. So that's gonna be another fun one. And then just another note, our fuse for this is a 3.15 amp at 250 volts. Very, very specific. Absolutely must be 3.15 and not 3 amps. So I think that's kind of interesting. You know, keep our fuse rating slightly above our input rating, right? And there's the data plate on our other one. So these are 2010 actually. Okay, interesting. These are a little bit older than a lot of the rest of the microscope. Okay. The fancy cousin of the humble microwave oven transformer. I think that the microwave oven, I mean, kind of, I guess. It's more like the scary cousin. Okay, so we're gonna grab just a few pictures real quick. So we're gonna switch over to photography mode here. Now we gotta wait for our camera to index. Still indexing, still thinking really hard about it. Hey, there we go. And then there should be a button to do that. There we go. Cool. Okay. Oh, hey, I can check something off the list. Oh, I should probably put the link to the... Why did it restart? I don't know why it decided it needed to restart. Now it has to reindex everything. You know, I might fix that indexing issue real quick and just throw a new SD card in there. But I was going to do something else first. I was going to put the link to the notes in the chat, in the description. So let me copy this link. Right, everybody, copy share link. Share link copied. So there is our link to all of our notes. So we have rotated, repositioned the SEM. Cool. Yeah, less screws for me. Less screws I have to deal with. They're saving me time. Saving me so much time. It's great. Love it when people save me time by taking out screws that I wish I had. Okay, if it decides to be weird one more time, I'm just going to change the SD card to an empty one, and that should help it out some. Let's see here, is HDR on? Yep, HDR set to dynamic range. Go neutral on that, lower that a bit. Bring up our aperture a bit. Ah, it did it again. Okay, we're fixing that because this is annoying. I do have a brand new SD card to put in it, so. It probably has something to do with the USB connection being just a little bit loose. But the problem is that every time it reconnects, Mac OS is like, oh, we need to know about every single file on this SD card before we let you proceed with anything. Despite it being connected via tethered capture, and I'm not reading the SD card in Capture One, I'm just getting the pictures off of it live and using live view, but oh no, Mac OS has to be satisfied first, so. That's how you're supposed to open this box, right? Close enough. We're doing great tonight. Okay, brand new card installed. That should take care of that issue. Oh yeah, links up almost instantly. Cool. Okay, take two. I wonder if this is gonna fix the weird, it jumps around a whole bunch kind of randomly issue. It almost fixed it. Not really, kind of. Okay, we'll see how that goes. Cool. So the it does just have the remote plug like jumpered out, so it's just shortening some pins together to enable the supply. And we don't want to mix up our CAN TX and RX. It doesn't have RX and TX labeled on the supply. Or I guess it does. Actually, yeah, it does. It's just from the underside. Okay, there we go. I might need to change lenses. I'm at really close to the minimum focus distance here on this lens. Oh, let's definitely get a picture of our dip switches. That's important. Do not want to forget what our dip switches are set to. That would be most unfortunate. Okay, let's get a serial number plate on our lower one. Overall state for lower one. Let's make sure we document the fact that both of our high voltage connectors are loose. Or sorry, not high voltage connectors, both of our grounds are loose. Just absolutely love loose high voltage grounds. That's what gets me out of bed every day. Get a good picture of our LEDs. Pictures of our cable labels. I like how the peel off film on the plastic on the Varian label isn't fully peeled off yet. That's fun. Okay, I think we've pretty much got what we came for back here. I do also want to get a picture of the state of the ground braid on this lower one, because it's very slightly degraded, but it's not bad. Not bad at all. Let's see if we can get a shot kind of shows inside the supply a little bit. Oh, that's fun. Check out back here. That screw is coming out. So we've got two missing fasteners, another fastener that's backing itself out. I guess that's not really a, that screw isn't one that holds the case together though. That's one that just is for on the mounting holes, I think. Interesting. We'll investigate that a bit more. Oh, they're also mounted on these slotted rails back here. So I think that's how we get the connectors out, is we just loosen them on these rails. So when I tried to get the high voltage connector out earlier, I basically couldn't. I like the heat shrink over the screws on the stage control box. Hopefully keep you from scratching yourself up too bad on them. So when I tried to pull this high voltage connector out, it's too stiff to be able to come out. So once we loosen up these on the slotted stuff here, we should be able to pull that right out pretty much. So yeah, cool. That's the outside of the ion pump supplies. I like that for now on in the set of Merlin reference photos I'll be publishing. There's just going to be a Christmas tree in some of them. Oh, this is probably a good thing to... Oh, did we lose it? Come on, you can do it. You got this. I don't know why it stopped live here. I just got one more picture to take, so I'll just get that picture done and then call it good. Okay, let's go back to video mode and get these pulled out. Okay, back into UVC mode. So anybody got any questions about what we're looking at so far? So far it seems pretty relatively self-explanatory, so I thought I checked off that first one. I guess I never did. Okay, let's dismount our IGP supplies. So, what tools are we going to anticipate needing? Plier wrenches, Allen keys, Phillips. Cool. And before I go get over there on the ground, I will put the big chat up so I can see it from all the way over there, hopefully. Actually, I will just put it up on the big screen. That makes more sense to me. Okay, let's go screen mirroring. Short throw 1. Choose content. Window or app. Choose window or app. Mirror this window. There we go. Why did the exposure freak out on the webcam? It does that whenever I screen share. Oh, the Logi Tune app is really not feeling it today. That's so weird. Okay. Cool. Let's get these supplies off. So we're gonna start on this side with just loosening them up a bit. One size up. There we go. These are already pretty loose. That one was tighter. I'm sensing a theme here with fasteners on this, and I don't know if I like it. In fact, I don't think I do. So now that we got that loosened up, let's get all of our cables pulled off of it. So high voltage is loose, we'll get the DC loose, and then we'll loosen up our can. Just slide it out. There we go. Is that the Kingfisher style? What is this one? Is that the SHV style? It's the Radial, which is a really common manufacturer of high voltage plugs like this. R3170720000. I want to say that's an SHV. Oh, I didn't even need plier wrenches for this. That was... I don't even think that was on there in the correct order. You're supposed to have the lock washer on the ring terminal. Huh. That's suspicious. Okay, so let's do the same thing on this one. We'll start at the top and go to the bottom. Let's get the can out. Let's get the DC 48 volt out, loosened. We'll get that loosened. Then with those, we can just slide our supply. Oh, I guess I never loosened those lower ones. Let me do that real quick. It's not like y'all have any choice, really. Oh, these ones are tighter. Okay. There we go. Let's get this ground off. Well, interesting. That one feels tight, but it doesn't look tight. And by feels tight, I meant just like hand tight, because it had just started to compress the lock washer, was all. Just not tight enough for protective earth like this. Oh, 2 for 2 for dropping washers on this one so far. See if I can go 3 for 3. A 2 for 3, okay. I'll take that. There we go. So we got all the cables out. Now it's time to actually pull the supplies out. So I think we'll do the top one first. I think we'll do the far screw last. Should get a screw container out for this. I'll do that after I get this off. Okay, there's our first supply off. Give it a good old sniff test. No, I don't smell terrible smells, so that's a great sign. We'll set that aside. Let's take our lower one off now, shall we? Do that in the same order because that worked out so well last time. Okay, there we go. That's our ion pump supplies off. So that's what it looks like with no ion pump power supplies. Isn't that fun? Okay, so that's taken care of. We're just going to temporarily close this door up. Why is that just hanging out like that? That's not... Okay, we need to reroute this particular optical fiber back into the bundle so that it hinges better instead of flexing on these constantly. But we're going to do that next time we open this door because that's actually what we're working on next. It is that box. So we're just going to close that door for now so we've got some more room to work. Okay, we have dismounted the IGP supplies. Check that off. Now it's time to disassemble the IGP supplies. So let's move some cameras around here and bring the cart up, and we'll put the supplies on the cart so I don't have to just work on the ground the whole night. Okay, we got all the screws. Put those in a screw bin. Okay. And this is, I guess, another cooking show episode. So let's get our cameras or our lights all set up for this. And let's get our supplies up on the table. So that's our lower one there. And that's our upper. Well, we got some here. We can do a OBSception. What cable am I tripping on? Oh, webcam. Yeah, we'll move the webcam too. Okay. I'm gonna do something to keep this door here in a little bit because I don't want to give myself a bruise on the leg from it. Okay, let's get these supplies opened up. I'm gonna start with the upper one. Interesting. These okay. These have got plastic washers on them. So these are electrically isolated, these screws. So the supply is not electrically connected to this frame. And that's going to be so that it's grounded only to the ion pump through the cable. So with the loose, so that means that basically with the loose grounds, we were pretty much running entirely questionably grounded high voltage devices that are high leakage current, high voltage devices that were partially grounded. Isn't that great? I love partially grounded high voltage, high leakage devices. That's, oh man. Cool. Ground your IGP controllers. Don't do this. This is bad. This is very bad. Oh man. So there's a plastic washer on here, right? Come on, autofocus, you can do it. So plastic washer on there. And then there's plastic inserts here so that the side of the screw can't touch this piece of metal either. So that's not a bad design. I mean, that's actually a good design. That way your IGP fault current only ever goes through your IGP ground cable and hopefully causes minimum havoc elsewhere on your microscope. So as we've been finding, this microscope's ground architecture is quite good. We got some dust buildup on our bracket there. So that's the side that was facing down, right? So just a little bit of dust. Enough, if there's that much inside the supply, we definitely want to clean that out. Okay, so that's the case off. So we do have these two screws over here. That one wasn't doing anything. That one was just loose. This one down here, I suspect, actually is a case screw. So this is actually one of the ones that was missing on this side, probably. Does this other one have the same pattern? It does. So there is like we got like two small screws and one big screw in the middle. Don't really know why that is, but it's what it is. So why are the two screws missing on the other side? Is something missing? Is there like a clearance issue or something? Like I think you'd want all the screws in. And these are posi drive. Two different sizes of posi drive, of course. I am looking for the larger posi drive bit. Did I leave that in the microscope? It's not it is possible in the microscope. Oh no, I set it right here because it was in the microscope and I took it out already. So it looks like they're using mostly inserts instead of, I haven't seen any case where they haven't used inserts for threads, which is nice because inserts tend to generate less metal FOD as you thread and unthread them. So that's great. Only one screw on this side. Who needs more than one screw, right? And it looks like these had a thread locker or something on them. Something yellow. But they're not at all hard to remove, so. Yeah, some kind of thread, something. Okay, last two screws. We're about to see how this thing works. About to find out, maybe about to find out if it's potted or not. Okay, it's getting caught in all the dip switches, so that's fun. I didn't switch any of them. Ta-da! Okay, so we've got our control board on top here. We've got a very overexposed camera still. Let me drop that down. Too much. That looks about right. So control board on top. Okay, I mean, this is making sense when you look at this edge, right? So like we got these three connectors. Well, three sets. There's four of them right there and two of them right there. And those are all on the top edge here. Got some socketed board right here. Looks like maybe a microcontroller. Starts with an A. I'm going to guess Atmega for some reason. We got this ribbon cable here that comes from this end. Oh, I blew on the board a little bit. There's a ton of dust in the air now. That's fun. Looks like we got some isolation on this side here, maybe. Definitely as we get further down this end of the board, the components start to get a little bit beefier. Okay, it is not potted, it looks like. So how do we open up the next part here? Okay, we're gonna need to get this. We're gonna need to get this connector off. And the standoffs, of course, coming out. I think that this L-shaped piece of metal here slides towards me. So we're going to take off these two screws on the high voltage connector. Wonder what the ground screw is going to end up doing, if that's going to have to come out. I bet that does. Let's take that out while I still have some screws on. Okay, so that did actually just loosen up that bolt, so we need to get that tight before we reassemble. I don't think we actually need to loosen that to separate this, but if we did, I wanted to apply torque to it before I had everything else separated. So there's a bunch of screws. There's a bunch of screws on this PCB, holding this PCB onto this box here. So I think this screw right here is basically our final screw to separate this thing. Ah, okay. It's the retention or the retention ring clamp on the 48 volt connector that's holding it together now. So let's get that pulled off. Okay, there we go. Now we got that free. Ah, okay. I see how that ground works now. There's the high voltage side. Oh, it's all conformal coated. Okay, we got some dust build up. That is a thick layer of conformal. Actually, that's not dust. That's just conformal dripping places. That's fun. Okay, what do we want to do here? This ground's on a quick disconnect, so we'll just pop that out real quick so we can get that separated. So that's the, that right there is the high voltage side of our supply. I like that they had the high, well, I guess the back of the board is facing up. And there is some dust on the back of the board. Yeah, it's basically dust we would expect, but it to be collected statically. So what have we got going on here? We got some diodes, some high voltage diodes. Bunch of capacitors. Are there diodes on the other side maybe? On those capacitors? No? And then to our output. Okay, interesting. And then so the control board's on top, but it's kind of interesting. The DC supply comes into this board down here and then goes up to like the control board. I don't know. Doesn't look like anything's gotten too toasty, so that's welcome. Welcome news. Love it when things don't get toasty. They masked off where on the board where the screws, mounting screws go from the conformal, so there's no conformal under the mounting screws. That's a nice touch. Oh, it looks like it's got current monitoring. It got a this transformer here with a loop going through it. Cool, let's switch to photography mode here and document this real quick. Decide if we're going to want to get to the back side of the board to blow it off, because that's actually where all the dust is on the back side of the board. So we are probably going to want to get to that side to blow it off. What is it, 6 screws to pull that off? So that's not that bad. Okay. Is there any problem setting this down this way? I don't think so. It looks like there's robust. I think we're just setting it on the connectors, basically. Yeah, that's good. Okay, let's switch to photo mode and get some photos of this supply. Encoding is overloaded. Why is encoding overloaded? That doesn't make any sense. No, we're not dropping frames, so I guess we're okay. We're going to switch to the 35mm macro lens, just so we don't have to deal with minimum focus distance issues. Let's really bring our lights in, or at least 2 of them in for photos. Love some good 3D high voltage soldering. This little daughter board here is kind of fun. I like the detail on all of these transistors, that little plastic piece underneath them. Autofocus did not like that detail. One singular isolation trench. That's funny. So that, where the isolation trench is on this side, that looks like the voltage, feedback for voltage, or maybe current, not sure which one. So there's two places, it looks like. So we got the transformer here, right? So that's driving the circuit. And then it looks like we got two places there and there where a trace crosses back over into the control section. So interesting. The back of this board looked really nasty. There's a bunch of crud on it. Let's pull this daughter board off, get some pictures underneath it. It's not keyed, so we want to make sure we get it back on in the right direction. Well, not the densest board by any stretch of the imagination, but not complaining either. Nice gold-plated connector they used on this mezzanine board. Okay, it's fully seated. Make sure I didn't offset the pins at all, and it is in the correct orientation. Okay, cool. Okay, so... God, why is that board so nasty underneath? Check out all that crap. What's going on? Why is there so much stuff on it? So I want to get to the back of the high voltage board because that's where I see some dust. But to do that, I would have to take all of the transistors off. It is on thermal pad, not on thermal paste. There is slots all around. I might try just blowing it off without pulling it off, because I don't really want to take the transistors off. All that being said, the conformal coating should help with any, we'll say, ignition concerns. Some dust buildup on the high voltage cable going to the outside. Not bad. Well, there's a serial number on the board. A lot of capacitance on the output. Well, a lot of capacitors, maybe not a lot of capacitance. Let me get a flashlight and I'll use that to kind of illuminate from the bottom of the board a little bit. Some interesting choices with the layout on the measuring resistor. So the trace goes underneath. Oh, we've lost all of our... Gonna come back? Let me just restart that completely. So the measuring resistor starts there, goes to the other side, but the trace also goes underneath it, and then comes to this node right here. And then from that node, there's a capacitor to the measuring side of the the instrumentation side of the measuring resistor, and that's what that cutout's under. And then we've got these two resistors that come over to our output. But that kind of means that the trace is a little bit close to the measuring resistor. So there's some type of arc through the PCB, I guess, which is relatively-ish unlikely, or from the resistor to that measuring resistor. Then you're going to cut your measuring resistor value in half, effectively. There is a lot of solder balls to configure stuff. You see on the LK4, LK3, LK2, LK1. So that's so you can change how the PCB is wired, basically, just by putting a blob of solder on or not. I'll get that camera taken care of. I'm gonna put some photos up real quick. Let's see here, library, filter.jpg. Okay, please stop lagging. Oh, it's really not feeling it. Oh, come on. Oh, I'm rainbow wheeling now, y'all. Oh man, this is not gonna, not a big fan of this happening on my streaming computer right now. Okay, it's feeling way more, I was about to say it's feeling more responsive, and then it stopped feeling responsive. Cool. Okay, let's filter by 5 stars. Go ahead and oh, I guess I didn't select anything. Okay. That's why there was no export settings. Is it exporting? Yeah, it's exporting. Cool. Oh, it's still generating previews. Why is it taking so long? The preview generation must be why it's being so weird in live view capture. And maybe that's what's causing my encoding overload issue? Huh, I don't know. Interesting. Interesting. Huh. Okay. Wow, this computer is not feeling it right now. CPU utilization's fine. Just like, everything's so laggy. Oh my god. Is it this preview generation stuff? It doesn't feel like it's preview generation. Is my stream link looking okay, y'all? Is it like jittering or anything? Because this computer doesn't feel okay, so I would not be surprised if my stream is not doing okay. Speed of preview generation, adjusting preview generation and preferences. Appearance, hardware accelerating auto. Maybe we optimize for speed of preview generation? Should not be chugging this hard. And I don't feel like I've had this issue before, too. You see some lag. What do you mean by some lag? Is it just like, is it jittery? Like, if I wave my hand, does it not, like, is it not smooth? Like, what's going on? Huh. That's weird. Okay, well, it says it's almost done generating previews, so let's see what it's done, what it does when it's done generating previews. Just a minute, it was like 2 FPS. Well, that's not good. I don't like 2 FPS. Okay, so it's done doing preview generation. No, let me, okay, let me turn off the other, I'm gonna turn off the one that's going to that monitor over there. Oh, and the webcam changes. Why does the webcam exposure shift by that? And I bet if I go to Logic Tune, I'm gonna look at the webcam exposure settings and they're not gonna have changed at all. But now it's all of a sudden much higher exposure. Unless I just click it for a second and it goes right back. That's, why does AirPlay to the TV do that? That's so weird, okay. Okay, so note to self, don't do what I just did, got it. Okay, I'm guessing it was because I was airplaying to the TV is why we were getting such weird results there. Okay, let's see here. So we've taken pictures of our first one. Haven't quite decided how I want to clean out the back of that board yet, you know? Like the back of that board's still a ongoing concern. So I'd have to take the transistors off. I mean, I do have more pads I can put under the transistors and I put the transistors back on, so like, yeah, tough call. Oh, I'm seeing the stream playback, and that's real laggy. Okay. Oh, it was really bad. Oh my god. Okay. Does it look okay now? Yeah, it looks okay now. Okay, don't AirPlay while streaming. That was fine before. Why was it not fine now? That's annoying. I guess I should have paid attention to the encoder being overloaded. And I was like, yeah, that warning, I can ignore that warning. Apparently I can't. Good to know. Okay, let's update our checklist. Okay. How do we want to clean these? I mean, compressed air, right? I will do it by an air filter. I'll make sure my air filters are running at max. Because if they were dusty, like really dusty, I would not be doing this, but I can barely see dust on them. At least on the parts that matter. And the one part that already had a lot of dust, I did just blow on and blew it off. Hopefully this doesn't sound awful. Let's put the camera back up. How does that sound, chat? Is that too loud? Should I mute myself while doing that? It's tolerable? Okay, the real question is, are you wearing earbuds? Because I don't want me to blast anybody who's wearing earbuds. Okay, actually that's a lot louder for me on that side, and I want ear protection for that. AirPods and other noise canceling headphones do not count as ear protection. They do not reduce the SPO. They just make it sound less loud. Well, this top board certainly looks a lot cleaner. I'm still debating if I want to open up that middle section or not. Have to mess with all the transistors then. What do y'all think, chat? Should I take the transistors off to get to the backside of the high voltage board so I can make sure it's clean? I mean, it looks pretty clean. I don't see dust on it. There's just one spot where I'm like, is that dust or is that just different thicknesses in the conformal coating? Because wherever the conformal coating is a little bit thicker, right, that like shows up darker. And it looks like drips, like it's just the conformal. And I could just like stick a Q-tip in with alcohol, but then I'm, if I get the board dust, if I do that on the board, I want to be able to like get a really good look at it to make sure I'm not adding contaminant more than I'm taking away contaminant. And to do that, I would want to remove it. So I don't want to just test it and find out if that's dust or if that's just conformal. So what I'll do is I will use a flashlight and we'll look at it very closely with the flashlight. And instead of, because currently it's being illuminated from the bottom through the PCB. So that's why it's kind of looking dark. Okay, that's not black dust buildup. That is just that's just thickness of the conformal. Okay. There is some dust back there. I would like to clean up down in there better. I'm trying to figure out how to do that. I just want to like stick a longer tube on the end of my air blaster here. Not terrible. It's not bad even. There is some though I want to get off. Okay, so how do we get air all the way down in here? Or do we just pull it apart? Because if we can just get air down there, that's going to do a real good job cleaning it up. It's just we can't because of the nozzle we got. So I'm going to go peruse my component selection real quick. What do we got? Those are some fittings that might be useful. So that's what's currently on there. Oh, look at that adapter. That's a useful adapter. That's exactly what we need, actually. Well, this is going surprisingly well so far. Haven't quite fully adapted to what I need to adapt to, but we're doing good to start with, so that's good. I need a reducer. That's not a reducer. Is this a reducer? Hey, I think we got our adapter made already. That's pretty fast. I'm actually happy with that. Okay. Here is the little boondoggle I came up with. So this happens to be another one of the OSHA compliant, relatively low noise air guns that I have just on hand. And on the other end of it, there is a push to connect, that 90-degree push to connect connector, which has the right threads on it. And so I reduced that down to a, I guess this is a 532nd OD, Norgen 150 PSI tube. And that will let us get all down in there, I think. If it were a little bit thinner, that would be nice. I might flatten it out some. But I can get down from this side, but I can't quite fit through those gaps, actually. So that actually, if I flatten it, let's see how I feel about if I flatten it. Still doesn't quite fit. Okay. If it were longer, if I had a longer piece of this tube, this very convenient tube, I'd have no problem getting back in there and everything. It's almost long enough. I just need a little bit more. So let me see if I got a slightly longer piece of this, and then that'll work. Or a longer piece of a slightly larger diameter, because I can just take the adapter off. And then I'll actually get more airflow that way. Maybe less velocity out of the tip, though. Tough choices. Well, I got a piece of tube that'll work right here, so that's good. Let me just snip a piece of this tube off. Where's the end? Where's the end? There's the end. Okay, slightly longer piece of tube procured. And the better thing to do would be to pull that block off entirely. Get a lot more airflow that way. But I'm not really restricting it that much, so this should be okay. These are the X Air nozzles from xair.com. EX Air. They're pretty good stuff. I think there's one company I found that I was like, oh, that's even cooler. But they're like even more expensive by like a substantial enough amount to be concerned about. Oh, it's different. Okay. So that doesn't adapt like I thought it did. Okay, we are just a little bit back to the drawing board. So we just need a connector that'll fit in the tip of our air gun. I should have that. So the deal is the particular X-Air tips I have are M6 for whatever reason. I don't even know. It's not even I think it's M6. No, it's a lot smaller than M6. It's like M3 or something silly like that. But yeah, it's a symmetric thread. It's not a it's not anything that air fittings normally use. That's for sure. Okay. Let's see here, we got some more parts. So I gotta see if I can get this tube out of here. If I can, I think this is the adapter I need. Oh, that ring does collapse, okay. Trying to get this tube out of this brass quick connect here so that I can use it in my blow-off tool so that I can get to the backside of the high voltage board on these ion pump controllers without... Am I muted or something? No, okay, cool. So I can get to the backside of the ion pump controller to blow it out. Without having to dismount a bunch of transistors from their heat sinks, which I don't want to do. So I think I found the right fitting. I just have to get this plastic tube out of it, or this piece of tube out of it. Come on. Come on. Please. Pretty please. Hey, okay, there we go. Well, that was down in there. Okay. Okay, so let's put that on the tip of our air gun. Hey, look at that. Now we're getting somewhere. Put our piece of tube on. Oh, well, it's almost the right diameter. It's not quite the right diameter. It's not wanting to stay down there. So this must be 1/4 inch and not 6 millimeter. It's just a 6 millimeter. If I hold it, that works, but I don't like that. Let me grab a piece of 1/4 inch tube. Let me grab a 1/4 inch to 6 millimeter adapter. 1/4 inch to 6 millimeter are like almost, they're so close to being the, and also let me grab tube cutters because the 1/4 inch tube I have is a little bit more firm and will not cut very well with flush cutters. Tube cutter. Okay. The one I want wasn't there, but one that will do was, so we'll go with that. Okay, there's the 1/4 to 6 inch adapter. 1/4 to 6 inch. 1/4 to 6 mil adapter. And we'll just cut ourselves a short piece of 1/4 inch tubing. adapt, 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 overcome. Okay, I think we got it this time. Okay, so that's the 1/4 inch size, so that goes in there. That might not be long enough. We'll find out. Good luck getting that apart again later. Okay, cool. There we go. Okay, we have successfully adapted and overcome. Oh, this is working great. We're using a lot more air than we were before. A lot more air. But I don't care. It's doing a good job. I'll let my compressor catch up a little bit. So yeah, be careful with a tube like this. It can plane around quite a bit. I can see where I've done and not done. So much fun, compressed air. Okay, I think we have successfully cleaned that. Awesome. So I think at this point, it's pretty much time to start putting this thing back together. Although we'll just give this side one more blast. Cool. We did it, chat. We've done it. I'm sorry for anybody who's wearing earbuds. Cool, that looks great. Okay, so I think we can check off, clean out the upper. Okay, let's get this one reassembled. Then we get to do it all over again. Isn't that fun? I'm also gonna take this tube out temporarily, so it doesn't accidentally whip around. Okay, so let's start with getting our grounding connector here. Oh, this needs to be blown off. You can see where the high voltage cable is. Then the light just right. Kind of see the reflection of the high voltage dust pattern on this. So we'll get this ground tightened up, and then we will get this side cleaned up. If I had to guess, just because of the particular texture of this metal, I don't think blowing the dust off is going to work entirely, so we're probably going to use some microfiber to clean the dust off this side. If the metal were shiny, or like polished, it'd be fine, but this texture has just got like a ability to kind of grab and hold on to dust, it seems like. Okay, we got that ground nice and tight now. I think we got it at the right angle too. We'll try blowing it off, see what happens. Yeah, we're getting the big stuff, but there is more to do. Kind of a cool design feature on this that I've noticed is wherever they're intending for you to mount a screw externally, like with these, it's closed on this end. It's an insert that doesn't go all the way through, so you can't get metal shavings from your mounting screws into an area where that would be a problem. So that's quite nice. I like that a lot. So I'm gonna grab some microfiber and I think some Windex, and we will get that cleaned up. And we will use a brand new microfiber for this because we don't want to risk contamination issues here. Okay, that cleaned it right up. Cool. Okay, I think it's time for reassembly here now. So what order do we want to do this in? Well, this goes in here first, so that's what we're gonna do. We gotta make sure we put that ground on. That's very important that we make sure we put that ground on. We'll just give it one last flash though. So let's set up to get that ground attached. How do we want to do this the easiest? Thinking like this. Let's go 180 degrees. Let's do it like this. There, that's the way to do it. Okay, we got the ground on, cool. Let's get the ribbon cable on, that's important. Blew the ribbon cable away a little bit, but no problem. Just give this a quick dust off. Let's get all of our connectors lined up. There we go, and we're in. So let's get our first two screws in, which are the two cheesehead Phillips screws. Get that one partially in. Let's get the other side partially in. So we're just gonna get these ones partially in, and then we're gonna lock down our connectors on the front panel. And then we'll get these tightened all the way down. That way we're not fighting everything. Okay, that's partially in. So now let's do our front panel. I think actually we're going to do the high voltage connector there as our next one. Okay, high voltage connector is tight. Now we'll tighten down our 48 volt connector. I'm actually gonna use a different pair of pliers to get that tight. Actually, let's do a little bit different. Well, maybe this pair will work too. Maybe we stick those are the right width, which they are a little bit wide. I trapped my pliers in these. Yeah, these are working a treat. Okay, got that tight. Cool. We got that tight, that's tight. Okay, now that our front panel is tightened down, we can go back to our sides here. And get these ones down and tight. So, nothing's potted. Isn't that great? Conformal coated, sure. Potted, no. Okay, it looks like the rest of our screw holes are lining up really nicely, so that's excellent news for us. Okay, so I think we're putting our case on now. There we go. Okay, so big one in the middle. I think we may have discovered why there wasn't one here last time, and this hole feels a little bit screwed up, so that's fun. Where'd my handle, my regular handle, go? Where are you? Where are you? Did I leave it inside the microscope? It's the last place I recall using it. No, doesn't look like it. This is why I have a tool cart, so everything stays on this one cart and I can find it easily, but appears to have not happened in this case. Huh. Well, I have stumped myself there. Okay, well, we can use the gyro handle as a regular handle and just not use the gyroscopic functionality. Yeah, this hole is a little bit messed up. Maybe a bit more than a little bit. Okay, I think we found the right threads there. Tough to say for sure, but it's in now, so I think that's what matters more. Well, let's do these ones up here first. Those seem to be, those are going to line a lot of different things up correctly once we get these ones in. And we're not tightening things down yet. We're just putting them part way in. Okay, we'll get this side in. Okay, let's do this side. Get a big one in there. There we go. That's the happy spot. Get that in there. Oh, and we're missing one, and it was missing before we started. So I'm actually going to transfer one from this side back to this side, because this side's accessible from once this is actually mounted in the microscope, and the other side is not accessible. Okay, now we can torque things down. Click. 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 Now for the big ones, that's a different bit. Don't know why this, but I don't know why they're big like this, but click. Click. Okay. We have completed one of the supplies. Okay, we can check off the upper supply. Okay, on to the next one. And we're not going to be reinstalling these into the microscope tonight. And that is because we're going to be working on the stage controller, and that is beneath these. So we're going to have a much easier time accessing those with these out of the microscope. So we're just going to leave them out of the microscope for now. Okay, so step one, disassemble. And theoretically, I should have all the tools and supplies out to do this time, so this should go a little bit faster. Okay, we got the mounting bracket off. So we're going to start with the exterior case. So let's grab the big bit, pull our two big screws out, and then move on to all of our small ones. Okay, that's our two big ones out. So now let's flip over to our smaller one. Let's get the plug out. Nice, got that out. These should be the same, right? Well, I can tell which one's which because one of them has a standoff in it, so. You do not need to take that off. We know that now. So now we can pull these out. Okay, I just want to pull that out just enough to not hit the dip switches. Okay, how's this one look? This one almost seems dustier. Interesting. And that's interesting because this one was on the bottom. So let's pull the ribbon cable out. Let's pull the front panel connectors off that we're going to take off. Or well, I guess just the mounting hardware for said connectors. I hid the tool from myself. There we go. Okay, that should be everything we got to pull off from there. Let's do our ones on the side now. Boop. Look at that. Yeah, this one. Oh. Well, that's a little bit different. There's a lot more dust buildup on the transformer than on the last one. Interesting. Let's get this ground off. Without hitting the capacitors that are right next to it. And set that aside, and there we go. We got that out. Cool. So we're going to switch back to photography mode here real quick so we can document the current state. This one's dirtier. This one's absolutely dirtier. That's interesting. Especially considering this was the lower of the two. Yeah, this one's a lot dustier. Huh. This has got some fingerprints in the high voltage area too. Now why is there fingerprints in the high voltage area on this one? Okay, that's interesting. Well, let's switch to photo mode, get this one documented, and then get it cleaned up. Figure out if we do have to take this one apart further because of the fingerprints. In the lower of the two supplies. Am I still streaming? I accidentally locked my computer. Okay. Interesting. Why is there a fingerprint there? Take these out for a bit. Oh, I've left this microscope pumping, so that's gonna be in the background on my audio. Let me go ahead and vent this. I'm not streaming? Wait a second. How'd you know I asked that question? Are you really good at reading lips? You're a funny one. Okay, that's set up. Let's do this. And then let's do this. Let's do this. Okay, so please let me know if it gets all weird, like my stream gets really laggy. Hopefully it doesn't this time. Oh, that's the live view, right? Yep, that's the live view. Cool. Okay, that should be all set up. Oh, and I can check off a box. I love checking boxes. Disassemble. Check. Cool. Okay, looks good. Love to hear it. Thank you so much. I not trying to do a like a slideshow for y'all tonight. We're doing video. Start with a picture of our high voltage dust pattern. So there's our top of board picture. Let's bring some more light in. Really? Why did you decide to cycle connection there? You gonna work well this time, please? One of those talkies, I know, right? Oh, look, they got the fancy D-subs with the round pins. And no video on screen. Okay, let's just recycle that. There we go. So last time I did 3x3 or 3x4 grid. I'm just going to do a 2x2 grid on this one. It's more for inspection purposes than being able to know exactly what chip it is. Presumably these are the same. And we should still have no issue reading chips or traces. Now this is the part where I just stare at it. really closely and ask it if it has any problems or anything it would like to share with me. Well, there's certainly some process indicators, to use IPC language, on the dip switches where things are maybe not soldered quite as much as they could or should be. What do you think about this, chat? How does this soldering make you feel? Wrong window. Give me that window. Give me that one. Yeah, okay. Have the photos imported? They have. Do I have that one? I do. Please load. It'd be so great if you load. Really appreciate it. Why are you being so slow? Are all of you being slow? You're all being slow. Is that because I didn't generate big previews, or are you just upset over the preview thing? I changed the previews to low quality, but I don't think this is what's going on. Oh, and it's, okay. Oh, it's when it generates previews. That's why it's jumping around, because of the preview generation. Okay, I understand more about what's going on now. I've never had, oh, the stream's getting laggy now? Like, is the stream, like, are we starting to lose FPS now? It was for a sec. Interesting. Hard to tell when the image was stacked. Okay, it's loaded the preview of what I wanted to load the preview of. So how do we feel about that soldering? Especially that one back there. That feels like empty. It's like, it's probably soldered on the other side pretty okay, right? And the through-hole plating should be sufficient, right? Right? I mean, it's not that this... it just makes me a little bit sus, a little bit sad. Absolutely love you. Okay, lovely. Okay, I appreciate your professional opinion there. No notes. No notes whatsoever on that. Well, unfortunately, I have to decide if I'm going to deal with this or not, or if this is something that absolutely must be dealt with, or is this acceptable to just leave as is? It's just the dip switches, right? It'll only make the supply, like, not talk to the microscope correctly, right? I mean, it's probably a solid electrical connection, you know? You wouldn't want it on a plane, and you wouldn't want it in a nuclear power plant, but is it okay for the dip switches on an ion pump controller on an SEM? Yeah, check the bottom's a good call. Let's do that. Let's just take a peek at the bottom. very similarly high quality soldering on the D-sub connector. But it's not power, it's not data. Well, it certainly looks away. They certainly tried. It certainly looks soldered differently than the rest of the through-hole components, so that's fun. I mean, okay, cool. How does that make us feel? It's wetted. It looks like they got both sides hot, I think. Maybe. Right there. Probably they did. I think this is keep rolling territory, considering it's just dip switches, but it's like, okay. Okay. Look at the bottom of the D sub where that's soldered too, because that it's not easy. It's not going to be easy to get a picture of, but yeah, it's interesting. It's like the rest of the through holes are not hand soldered, but those ones are. No, that's a blurry picture. How about that picture? How about that picture? That's not bad. Oh, that's the blurry one, actually. It's also a bit blurry. I was doing all these handheld, where the camera and the thing was handheld, so that's why it's not as good. But we can see there's some similar things going on with the D-sub. But I think it's okay, because it's like, it just has it has a wire that goes out and back in, and then it has another wire that goes out and back in. That's all that happens on this D-sub connector here. You know what's funny is that the, this is fun. This thing's entirely controlled over CAN. It's entirely controlled over CAN. There is no, the connector, like the interlock and remote control connector that has like the pins you open and close to turn it on and off via like a hardware feature. It's just jumpered out. So like, are they using like keep alives or something? Like, do you have to like tell it every like second, like, hey, stay turned on via the optical CAN? Like, I don't know. I mean, that's, we should unplug the CAN at some point and just be like, does it turn off or does it just keep going? Don't you want to know if it turns off or if it just keeps going if you, like, something freezes? Sniff it? Yeah, I'll lick it. I'll lick it and I'll let you know. I know, I know. I like this. This is great. This is good. This is quality stuff. Okay, looking very closely at things. The SMD soldering looks pretty good. Oh. Oh. Is that the only one? What's going on over there? It's not. God damn it. That's not capacitor goo, is it? Shit. I think there's puffy caps. Okay, this whole this is going downhill fast. Okay, so what have we noticed? We have some notes to take. Yay! We got rework over here. I almost want to get the 100mm macro out to show this to you in exceptional detail. Oh, the camera lost connection in the middle of an HDR processing? That's not good. Oh, hey, it managed to process it. Okay, okay. Let's recycle it though so we can get... Oh, and the preview generation's doing things now. Okay. Okay, we got that back. So we got one transistor over here that's been reworked. We got some bad soldering on one of these diodes here. I think we have a capacitor that's leaked. It's a really small electrolytic one too. Okay. That looks like electrolyte. Okay, so check out these three capacitors here. So the two on the left are round on top. I'm gonna poke it. Yeah, it's pretty solid. It's kind of hard to get a good picture of how round they are. Oh, no, it's not. And then on the one in the middle, I see what looks like capacitor goo. I'm pretty sure that's electrolyte. Okay, what else do we notice? The transistor that was replaced looks like the RX for the fiber, actually, interestingly enough. got some poor soldering on what I'm gonna guess is a voltage regulator. How does that look on the back side? Yeah, it looks okay on the back. But I'm pretty sure at this point this board's coming out because of that capacitor. Here, we'll zoom in on some capacitor pictures for y'all. Okay, yay. Love this for us. Oh, I should get a clearer picture of that. Oh, is it still, it's not generating preview still. No, it is generating preview. Or it's just loading this one in particular. So that looks like a leaky capacitor to me. I think we've already lost the electrolyte on that one. And then here's the okay. So that's the not bulged one. And that, yep, that's a failed cap. That's a failed cap. Yay! And we're not even looking at the high voltage side yet. This is the low voltage side. Okay, so that's not good. Here's what's going on that. Presumably a power regulator. We can look it up in a sec. Just not soldered particularly well. That is a voltage regulator, right? L780SCV. Oh, let's take some notes. What caps are these? Questionable soldering on the D sub, DIN, one of the diodes, and voltage regulator. It's not DIN, it's dip. Several electrolytic capacitors are bulging, and one of them appears to have leaked electrolyte onto the PCB. Needs to be replaced. Isn't that lovely? Okay, let me get a better picture of that leak. Ugh. Damn it. This is not what I was hoping for. Oh, there's a good picture of the leak. Yep, that's a leak. Yay. Okay. So we know that this PCB is coming out now. Let's pop the microcontroller out. See what we find underneath it. Okay, it's looking pretty okay. That's good. Is that a ROM chip, maybe? Oh, Atmel 0920. I asked if that's a ROM because that one looks like it was hand soldered in. Oh, we also, let me take a note on the, some IC on the, very good QA, I agree. Excellent QA. Or somebody after the factory messed with it, right? Let's get good pictures of the values in these caps. Well, they're 105C rated, 25V47. Okay, who makes them? So the lower supply is worked harder than the upper supply. Because it deals with all the gas coming out of the chamber, you know? It's funny how much taller the burst ones are. Okay, where's a ruler? So now we also need to measure the width and the height. At least we have one that's not blown up so we can get a marginally more accurate measurement. Not that it really matters, but we're gonna measure width and height of the cap so that we can determine exactly the model of the cap that we have in here currently so that we can then determine the width of the capacitor leads so that we may then replace those. I know that I had a ruler in here because we did a lot of rulering on the, that's the technical term for it, on the DC supply. So where did it go? Where is my ruler? Oh, it's right here. It's on the microscope. Of course it's on the microscope. Okay. If one of you could just put this down in the chat, I can add it to the notes. But the width is 6 millimeters. And the height is 6.5 millimeters. And the one that's burst, you can see it's come up off the board too. It's kind of funny. This is why we look at every single circuit board closely. This right here is exactly why we look at every circuit board so closely. Okay, let's document the other cap we got on here. .25 volt, 100 microfarad. It's a Rubicon. It's a Rubicon, a YXF. And let's check out the height and width of this one. Okay, height is 11.5 millimeters. No, it's 11.5 miles, right? No, it's millimeters. It's millimeters. Width is 6 millimeters. I believe the others are Rubicons. They're too small to have the Rubicon. Oh shit, that deleted the messages? Oh no. I clicked the wrong, I didn't think that was gonna do that. What? That's not what I wanted. That's not at all what I wanted. What did I click? How did I delete all messages? I'm so sorry. God damn it. I was supposed to, I'm sorry. That was not what I was not trying to do that. I don't even know how you, so if you put somebody in timeout for 10 seconds. So if you put somebody in timeout for 10 seconds, it deletes all the messages. Great. I'm sorry about that. That was not the plan. Well, I can recover them, but I can't put them back up. But I can still see them. Okay. I won't do that again. Okay. I'm sorry about that. I thought a 10-second timeout would be funny. Somehow this is, I think somehow this is funnier, but I am also sorry. Yeah, I haven't really had to use the moderation options all that much. So yeah, that's what I get for that. Didn't I get pictures of the tall boy that showed me the value? Thought I did. Yeah, I did. Okay. $25V 100 UF VXF, right? Is that YXF or that's YXF? YXF. Tubicon. No, Rubicon. Rubicon. 6mm width. What do we say? 11.5 or 11? I think we said 11.5. Yep, we said 11.5. 11.5mm height. Okay. So that's what we got blown out so far. I'll show you all the bottom of that cap that blew out because I think it's funny. Well, I guess there's two that actually blew out. Okay, that's funny. Oh, and my DSLR died. The battery died. So check out the bottom of that cap. That cap's experienced something. it's gone through something, and that one's also, the one to the right of it is also one that has been lifted up slightly. So yeah, look at the the whole top of the capacitor is like coming off. Isn't that great? Isn't that just great? Don't we love that, chat? Isn't that amazing, chat? I love that for us. Cool. Let's see what else we keep finding. I was a little bit bored. I was like, oh man, you know, I'm gonna open this up. It's right. I was a little bit bored. I was like, you know, I'm gonna open this up. Probably won't find anything. Probably just looking at stuff. You can't get complacent. You know, it's like, because then you find shit like this, and you're like, come on. Okay, let's flip it over. We haven't spent any time looking at the other side yet. Well, I spent a little bit of time looking at the other side. I did notice a few things on the other side already. This one is just dustier. Crustier. Well, the caps on this side look like they're okay, so that's good. That being said, they're probably going to get replaced too. My brain is refusing to process what's going on with one of these transistor clamps. Okay, the additional lighting has only served to make me more confused. What? What on earth? How is that even? I do not understand what is going on here. That must just be... Nope, not that one, it's this one. So I'll show you all what's going on here. Or why my brain is broken. Oh, I had this window in an unfortunate spot. So there's this. Where and how is that piece of metal doing its thing? Like, I don't understand where that is coming from or how that is happening. Like, what is even going on right now? Well, it just doesn't make sense. Like, because if we look at the other side is what I was pointing to here. Like, does that piece of metal go through? Is that what's happening? I don't think so. I think the piece of metal is just on the surface. I don't think it loops all the way back through. I'm like, how is that even a thing? That's what I thought when I saw it too. I was like, it's just phasing through, no big deal, or whatever. I'm gonna poke it, see what happens. Okay, it was just hanging out. Fell off. So it was just like stuck to the thermal pad, which is kind of what I thought. Okay, love the FOD that just fell off when I poked it. And you kind of probably saw how it was like bending around some. Don't you love it when you got a piece of metal that could just fall off at any time inside of your 7 kV relatively high current power supply? Just keeps getting better. Where it looks like it came from one of the transistor clamps, but I don't see where it would have come from. No, it was exactly like it looked exactly like the heatsink was like a little bit AI generated. I was like, what? This picture. Well, I can't tell you who the builder is. For those of you who watch inspection shorts, I can't tell you who the builder is, but okay, cool. This is getting great. Well, I'm not putting this back together tonight. We need parts for it now. Okay, what else do I notice? No, when I first saw that, I was like looking at it, I was like, what? What am I looking at right now? I was very confused. I was like, this doesn't make sense. I'm hoping I don't find anything to have to resolder on this side, because this side's conformal coated. That doesn't sound very much fun to be dealing with conformal coating. I mean, it's not terrible, but it's not fun either. Solder balls, anybody? Let's get our overall pictures of this side. Little bit more grimy on some parts, and a lot more grimy. Well, okay, a lot is relative. Like on this cutout, there wasn't anything on the other one. These are both the same year, so I don't really know why this one is showing so much evidence of wear. AI generated heatsink clip. Like that is exactly the type of thoughts that was going through my head when I saw that. I was like, what? This doesn't, there's not supposed to be a piece of metal coming through the heatsink pad right here. So let's just check the fuse on this one, just curious. Oh, I can't really see, I guess, okay. It is 3.15 amps, that's good. Three point 14159. Yeah, exactly. It had to put out a ton of current the one time the intern grabbed it. Yeah, something like that, right? Oh man. Okay. God damn it. Okay. I have to deal with this. So what do we want to do here? Do we want to? I mean, we can just replace the caps, right? Just go full part swapper. When you say replace those with good ones, are you referring to the fuses? Okay, so we know we need to replace the caps. Wait, we'll replace the supplies with good supplies? I mean, oh man, no, I don't want to deal with CAN on this thing. I have to make it pretend to be it, and I don't want to do that. That's like a lot of work. It's a lot of work to pretend to be somebody. It's a lot of work to pretend to be somebody that you're not. I don't want to pretend to be a high-tech high voltage power supply. So I need to replace the caps. Look, after I just lightly tapped it, it just fell out. Look at that. It just like touching the delete of the device. It's good. It fell out and went between the lead of the device and ground. Like what could go wrong? That's great. Isn't that funny? Like I just want to know how it got there. It's just so funny. It's just sticking straight out. Like that's amazing. Yeah, you could do it. So that's probably filtering cap for the voltage regulator. That cap doesn't look bad. What I want to know is what do these caps do that they are like having issues like this? And should I be preemptively ordering other components in the circuit here? What is a UC 3843A? It's by On Semiconductor. It's an SMPS controller. Oh, I get it. So this area is probably well, there's several things that are going to be needed to drive the high voltage section. $8610A. What is an 8610A? Step down regulator with a 2.5 microamp quintessential current. Okay. Something there. Am I sure about what? The number? What it does? On that one? UC 3843A. Yeah, UC 3843A. It's a Fairchild. Or, I mean, I have a Fairchild data sheet. Who knows if that's a Fairchild part or not, but. So what you do? No, the preview one. Okay. 8610A? Yeah, okay, there's an AD number there. It is an AD logo. And I am on the analog website. And I'm looking at the 8610A, and that's a synchronous step-down regulator. There's another one. I want to know what the capacitors do. So my question basically is, should I just swap the caps and then look for signs of life in this thing? Or is there other components that I should be preemptively replacing? I mean, it makes sense that if you're going to blow up a capacitor, it's probably going to be on the SMPS, right? Like, and I got well, hopefully we didn't kill anything else, right? Hey. I don't think it got really toasty. I mean, I'm just like, used to like, oh no, the electrolytics and the SMPS went, and now all of your transistors are also blowing up too. I don't think this thing got especially toasty. The transformer does not look super toasty. Okay, there's some other capacitors in the back here. Let's get those documented so that we can also get those replaced. I mean, I said it does not look like they got toasty. They look They look like they remained at relatively ambient temperatures. Okay, and I got a few dimensions that if somebody could record, that would be great. So the width on these capacitors is 15 millimeters. Well, 15.5 millimeters. And the height is 37 millimeters. So 15 and 37. Ah, yeah, that makes sense. I'll look for a brand on these. I haven't seen a brand on them yet. M. Okay. CEFC? Yeah, CEFC. Okay, so presumably good old High-powered wire resistor. Yeah, optical indicators for shorted. High-power wire resistors are indeed excellent visual indicators for when your FET shorts, and the resistor just starts glowing. It just starts glowing. You know, incandescent. You know, usually you see like neon bulbs like used as like indicators or something like that. But no, you can just use a resistor. It's fine. It's incandescent. It's great. Okay, so that's probably our FET. That's I think the only big one. Okay, let's grab the meter. Where's the meter? $7.48 kiloohms. $22 ohms and rising. Where's a ground? That might be ground. That's a ground. 17. Okay, and rising. Okay. I don't see any other FETs. Anything on the back? Nothing on the back. So that looks like our only FET. No, there's a couple of devices over here on the right. Yeah, we'll just check for some shorts there. So the ones I'm checking right now are a 4-pin transistor, or just 4 pins. And I suspect that 2 of the pins are connected together, and they are reading short. But we're gonna verify that. So the ones I'm getting a air quotes short on are a FZT. It's FZT751 and an FZT651. That's an FZT651. And it's from the center pin to the thermal spreader. But I'm guessing those are connected. So this is what I got. Did measure a short between the left pin and the center one on the right there, but I'm guessing that's intentional. Yep, there, that's the collector and it's connected together. I'm gonna post up some pictures. So that y'all can look at what we're looking at in as much detail as you want. Yeah, that's what I was thinking. It's just starting the center of the top paddle. Okay, getting these posted now. Okay, I got the pictures posted into the SEM Hackers Discord under the Merlin FEG channel. Okay. So now what? Well, I think this is I think this is where I don't know what else to do at this point. I gotta order caps. I think we've, unless you can come up with anything else to investigate, I think we investigated what we needed to investigate. Yeah, I can't really think of anything else to test at this point. I mean, we know it needs some attention, so I gotta order caps, and yeah, I think that's it. Cool. Well, I appreciate everybody for being here. That was some fun stuff. Always love finding. Always love finding little goodies like that, right? Isn't that just great? Cool. Well, I think with that, I'm going to say goodnight to you all. So long, farewell, and thanks for all the fish. And thank you especially for the help with the exploration of the problematic board that we just found. So, or problematic components on the board at least. So. Peter, Monochroma, Maria, you all have a wonderful evening, morning, day, whatever it happens to be for you. So cool. I will see you all tomorrow night or tomorrow. Bye.